Okay, to determine if this is a root of this polynomial, we need to first find the factor that yields that root, which is what we just did. So I'm going to set x equal to 5 radical 2i, square both sides, and I'll get 25 times 2 times I squared, which is negative 1. So x squared equals negative 50. So the factor that yields that root is x squared plus 50. Remember, we talked about if this is a factor, when I divide, I will get a remainder of 0. So most people probably prefer to do synthetic division, but since this is a quadratic factor, I can't do synthetic division. I have to switch to polynomial long division. So let's do x squared plus 50 into 3x to the third minus 4x squared plus 150x minus 210. And see if we get a remainder of 0. So start with x squared. What do you multiply x squared by to get 3x to the third? That's going to be 3x. When I multiply back here, I get 3x to the third. And here, I get plus 150x. Let's subtract. Bring down the negative 4x squared. The 150x cancels. Minus 210. And start over. What do you multiply x squared by to get negative 4x squared? That's going to be minus 4. Negative 4 times x squared is negative 4x squared. Negative 4 times 50 should be negative 200. So when I subtract, I get a remainder of negative 10, which means x squared plus 50 is not a factor, which means 5 radical 2i is not a root. If I asked you why, which I will on the test, you will say there's a remainder of negative 10. If it was a root, the remainder would be 0. So pause the video, try this one on your own, doing the exact same thing we did on the last slide. For this problem, you get a remainder of 0, so I can say yes, 1 minus 4i is a root. If I asked you why, you would just say simply, when doing long division, the remainder is 0. Okay, quickly, we're going to go through how to do different regressions in your calculator. So you can determine with a table if the table represents a linear, quadratic, cubic, or exponential models. If it's linear, the first differences are the same on your y values. So here's what I mean. 37 minus 29 is 8. 29 minus 21 is 8. 21 minus 13 is 8, and so on. The first differences are the same, so that table is linear. But if I look at C, 25 minus 16, we have 9, and then 7, and then 5, and then 3. It's not linear, but if I do my second differences, they are the same, so it's quadratic. If we look at B, you can go through and check all of the differences, but they're not going to be the same first, second, or third. So for it to be an exponential model, you have to divide. So if I do 512 divided by 128, I get 4. 128 divided by 32 is 4. 32 divided by 8 is 4. And 8 divided by 2 is 4. So this will be exponential. Next, I'm going to show you in your calculator how to determine which model to do. So what I want you guys to do, if you don't already, have your graphing calculators out, get them out. And then you need to check the mode of your calculator. So hit mode. Make sure that your stat diagnostics are on. If you have a newer calculator, you can do this just by hitting mode. If you have an older calculator, you need to hit second 0. So second catalog. Scroll all the way down till you see diagnostics on, and then you need to hit enter a few times. So that will take you to enter 1, 2. You just hit enter twice, it will say done, and you're ready to go. So here's how we're going to do this. We've already done it with quadratic in our quadratics unit. So I'm going to go to stat, edit, and in list 1, I'm going to put my x values, so -9 and 5. In list 2, I'm going to put my y values, so -24 and 4. So do stat, edit, in list 1, -9 and 5. In list 2, I need to do -24 and 4. Then the next steps are stat, calc, and then you have to pick a regression. So first I'm going to try linear regression, which is number 4. You'll see that you have an r squared value of 1. If r squared equals 1, that is the correct regression. So y equals 2x minus 6. If r squared did not equal 1, then I would need to go back and do stat, calculate, and then try quadratic regression, and then cubic regression, and so on until I get an r squared value of 1. So let's try number 2. Go to stat, edit, in list 1, type in 1, 4, -3. In list 2, type in 45, 12, and -117. Then go to stat, calculate, linear regression. And do you see for linear regression, your r squared value is 0.64789. So it's not linear. So let's try it again. Same numbers. Go to stat, calculate, try quadratic regression, and you get an r squared value of 1. So that means this is quadratic. -7.36x squared plus 25.79x plus 26.57. If you are not getting the same numbers as me, ask someone around you to see if they can show you what to do. All right, let's move on to number 3. So the steps are stat, edit. Now in list 1, I'm going to put -2, 0, 6, and -4. In list 2, I'm going to put -32, -8, 16, and -104. So let's do stat, calculate. When you try linear regression, your r squared value is 0.73. So let's do stat, calculate, and try quadratic regression. My r squared is 0.98, so it's closer to 1, but let's see if we can get it at exactly 1. So do stat, calculate, try cubic regression, and I get an r squared value of 1. So y equals 1/2 x to the third minus 3x squared plus 4x minus 8. So if you go through all of the regressions and you don't get an r squared value of 1, just pick the one that's closest to 1. Okay, for time's sake, let's skip number 4 and move on. Okay, these are just going to be review questions, so I'm going to stop here, and when I get back, we will go through these. We'll probably start the lesson tomorrow with these. So your homework tonight is a 2.7. Look at your assignment sheet because you have several problems on the second page, I think, of your assignment sheet in addition to the bookwork. So make sure you do the correct things. Write down any questions you have, and you can ask me when I return.